Well, there's also different theories of evolution. One of them was propounded in 1809 by Jean-Baptiste Lamarck. And he came up with two laws. One is the law of use and disuse, and the other is, well, the law of use and disuse says that creatures interact with their environment, and through that interaction, they change. And his second law, the law of the inheritance of acquired characteristics, says that these changes that are created within the environment get passed along to offspring. So if you look at the little diagram on the left-hand side, there's two animals. The one on the left is browsing at low-hanging foliage. So over time, that animal doesn't change. But the animal on the right is reaching for foliage higher up. And in reaching for that foliage, it's stretching its neck and stretching its legs, and they're growing stronger. And these changes are getting passed along in whole or in part to the next generation. And that generation, again, reaches for the higher foliage, and its legs strengthen and its neck lengthens. So after a time, you have a giraffe. Well, let's look at this law of use and disuse. It rings relatively true, because we know if we enter into a weight training program, we're going to build muscle. We know that if we stand and sunbathe for a period of time, that we're going to tan. Our skin will turn darker. And we know that if we run barefoot over a period of time, that our feet will toughen and grow calloused. So this part of it sounds about right. But what about the second part of it? The law of an inheritance of these characteristics. That one we're less certain about. Doesn't appear in our experience that muscles get passed along, or that tan skin gets passed along, or that the calloused feet gets passed along. So that one we have a little more trouble with. And it turns out there was a German biologist in 1889 named Weissman who conducted a little experiment to shed some light on Lamarck's theories. He took a population of 50 mice and he cut off their tails. And then he allowed these mice to interbreed, have babies, grow up. When they reached adulthood, he cut off the tails of those mice. And he continued this generation after generation for 22 generations. Now, mice mature in 3 to 4 months, so this is an experiment that took place over 5 years. And if Lamarck was right, excuse me, you would think that the tails would be shorter at the end of the experiment. But the fact of the matter is, the tails at the end were exactly the same length as the tails in the beginning. So actually, Weissman should have been able to anticipate this result. More than 1,000 years of circumcision hasn't changed the length of the size of foreskins, at least according to my Jewish friends. But in any case, Lamarck's theories are a little more complicated, but this is only one of many, many experiments that have shown that his theories really don't hold up, his second law particularly. So in about late 1889, there was an argument put forth, intelligent design. I mentioned it a little bit earlier in the case of Kitzmiller versus the Dover schools, in which the Supreme Court declared that intelligent design was another form of creation. Well, intelligent design is expressed usually in two different ways. One is the irreducible complexity, and the other is specified complexity. And basically what they say is that there's certain systems or components in the living world that can only be, that are so complicated and so intricate that they can only be explained if there is a designer that created them. It's called a teleological argument. Thank you very much. It's called a teleological argument. And the analogy is that of a watchmaker. It's inconceivable that a watch could be put together from a small series of small step by small step through selection, natural selection, till you got to a watch. A watch requires a designer that has in mind creating an instrument or a tool to tell time with, and then designs it along the way. And people who adhere to the intelligent design arguments used the example of a flagellum. A flagellum is a tiny little hair that is in some single cells. For example, a sperm cell, the little tail on it is a flagellum. And the molecular structure of that flagellum that allows it to go around in circles is fairly complex. And people who adhere to intelligent design say that it's inconceivable for this structure to have been put in place without a creator who began with a purpose, with an idea in mind before they got started. So let's look at Darwin. Let's go back to our old friend Darwin. Darwin was unusual in that he began with a series of observations that anyone could validate, anyone could make if they wanted to take the time. For example, he says that all species can reproduce in great numbers. And we know from our experience that to be true. Most of you have had experience in your kitchen in the summertime with a couple of fruit flies, and before you know it, you've got 100 of them. A family of 6 mice can end up over the course of a summer or a course of 3 or 4 months into a village of about 60. Even human beings, under optimal conditions, a human family is about 6 children. And if given 100 years, and there's a few cases in history where this has occurred, a human population can multiply 20 times over in a 100-year period of time. So despite the fact that all species can reproduce in great numbers, Darwin noted that in each generation, the numbers tend to remain about the same. You can say the human population is an exception to that, but that's part of one of my next talks. Anyway, all numbers remain about the same. So what he assumed, or the assumption he made from this, the conclusion he came to survive among those that do exist. So continuing now with his observations, he said that he noted that there is variations among each member of a species. Now, obviously it's true with people. We look at every person is different from every other person, with maybe the exception of identical twins. But it's also true for turtles to tigers. Every individual is different from every other individual in some small, minute, but measurable way. So if that were true, then his assumption is that some variations must be more favorable than others in a given environment. For example, I stand 5 feet 8 inches tall. And in the environment of a professional football team, I wouldn't stand a chance. So then he said that these variations, those that an individual is born with, these in fact get passed along to the next generation. So his conclusion, therefore, was that change can occur over time, and that given enough time, a great deal of change can occur. So let's go back to Weissman's experiment with the mice. So instead of approaching it by cutting off their tails, if you look at a population of 50 mice and measure their tails very carefully, you're going to find out that some of those tails are just a little bit shorter than some of the others. And if you pick the ones that have the shortest tails and you breed them together, allow them to grow up and measure the tails again, you're going to find that the ones in the next generation also have shorter tails. And if you continue this for the 22 generations, each time picking the one with the shortest tail, breeding them, letting them grow, and so forth, at the end of 22 generations, you're going to find that the mice at the end has significantly shorter tails than the ones in the beginning. And if you continue this long enough, the tails will disappear altogether.